Hello, college algebra students. This is section 2.3, and we're looking at functions as graphs versus functions with a written rule like an equation. And so when we talked about equations in the last couple of sections, we looked at functions such as f of x equals x squared plus 1, and we looked at what the function was telling us to do with an input. And so now what we're doing is we're looking at that same function idea, but with a graph. Um, in general, your graphs will be a little bit easier to visualize as well as interpret. And so that's a positive with regard to how we're going to look at functions now. The input of the graph will be, or of the function will be on the horizontal axes of the graph, and the output, or what the function gives you in return, will be on the vertical axes. So in example one, we have a nice simple graph that gives us the time on the x-axis. That's x. That's going to be time anywhere from noon to 6, or I guess 7 p.m. And then the temperature is going to be on the vertical axes in degrees Fahrenheit. So if we're looking at some selected values such as T of 1, T of 3, and T of 5, we're looking at an input of 1, 3, and 5. And that means that we go on our horizontal axes, we find 1, and we travel up to our graph. We identify the point, and we're looking for the output, which is on the vertical axes. So T of 1 would be 25. 3, we would be right around there, which looks like it's about 30 degrees Fahrenheit, and then 5 would be here. That looks to be about 20 degrees Fahrenheit. So I'm just going to list those out. So T of 1 was 25 degrees Fahrenheit. T of 3 was 30 degrees Fahrenheit. And then T of 5 was 20 degrees Fahrenheit. Okay, so when we're taking a look at which is larger, the graph kind of helps us here just because we can just look at which one is higher on the vertical axes. So between 2 and 4, we have 2 here, and we have x is 4 there. So clearly T of 2 is larger because it is higher on the vertical axes than T of 4. Okay, so there's A and B. For C, we're finding what values of x are produced by T of x equal to 25. So this is sort of the opposite. Instead of looking at an x value and trying to find a t value, we now have a t value, which is 25. So let's say this is 25 degrees Fahrenheit right there. And if we kind of travel across the graph, we're trying to figure out where does the graph hit that 25 degree mark. And that's going to occur right here at about 1, as well as there at 4. So the x values that produce 25 degrees would be 1 p.m. and 4 p.m. All right, moving on to part D. For what values of x is t greater than 25? All right, so this time we are looking at it a little bit differently. We're looking at a region. So we know that T is 1 and T is 4 give us a temperature of 25 degrees. We're looking for everything that is everything that is above that or equal to that. So we're looking at this whole region of the graph that I'm shading in, which is either equal to 25 degrees or larger than 25 degrees. So that's going to be an interval. That interval will be 1 to 4. Or I suppose you could say 1 p.m. is less than or equal to x, less than or equal to 4 p.m. as well. Okay, now we're going to do the net change between 1 p.m. and excuse me, and 3 p.m. So 1 p.m. is here, and 3 p.m. is there, and so we're kind of just trying to figure out how much change is there between the two of those. So T of 3 minus T of 1 will give us our net change. T of 3 is 30 degrees Fahrenheit, and T of 1 is 25 degrees Fahrenheit. So our net change is 5 degrees Fahrenheit. Okay, so there's example 1. The domain and range, which we've talked about a handful of times now, is kind of formally defined here. On our graph, the input, which is on the x-axis, will define the domain, then the output, which is on the y-axis, will define the range. So the domain is all of the x values that are possible in the function. The range is all of the y values that are possible within the function. Okay, let's go on to the next page. All right, for example 2, we're going to start taking a look at some specific examples. I don't have this one graphed on the calculator to show you. You can certainly grab your calculator and graph this one, or if you'd like, you can also use the MCA calculator. But this is going to be the top half of the circle, and the circle is centered at the origin, and the radius is 2. So here are the x intercepts and the y-intercept. And we've actually looked at this graph not too long ago. All right, so we're looking at the domain, which is going to be all of the possible x values. And those values will be between -2 and 2, and both of those can be included because the square root of 0 is totally fine. So if you think about, plugging in any x value, excuse me, between -2 and 2 into the function, then you're going to get a y value in return, and we can see that visually now. The y values are anywhere from 0 to 2. Okay, for example 3, the two graphs are actually given to you rather than put them on the calculator, which again you could certainly do. They're written out for us. I needed to graph these just to figure out the points of intersection. I'll talk through that with you all in the next lesson, I think. This point of intersection is -1/2 and 7/2, and then this intersection is 3/21. So again, don't feel like you have to be able to see that just by looking at the graph. We would be able to do that in our calculator using the intersection option. Anyway, so when we're looking at when 2x plus 3, remember this is the same thing as f of x. This is the same thing as g of x. So when we look at 2x plus 3 equal to 5x plus 6, we're really asking when are f, or when is f and g equal, and graphically that means they're going to intersect. And so that occurs when x is -1/2 and when x is 3. So we're looking at the x values there. What x values make those the same? The next one would be when f of x is less than or equal to g of x. And so on your graph, you're going to look at just visually when is f of x lower than g of x, which that occurs in this red region that I'm highlighting here. And so that interval would be from, -1/2 to 3. Remember, those are brackets. That's a closed interval because the inequality is also equal to. And then the last one would be when f of x is greater than g of x. And so we're looking for when is the graph of f of x above g of x, which is going to be this region that I'm highlighting in green. And remember, that's also an interval. This time it's open, so it's going to be -∞ to -1/2 with parentheses, and then from 3 to infinity. And again, that's open because the inequality is not also equal to. Okay, and then the last one on this video will be example 4, and this one we do need to graph, and so I don't really have a great way of showing you that on a calculator, so I took some screenshots of that. So what we're going to do is we're actually going to balance this by subtracting 2x squared and subtracting 5x from both sides of this, and so we get this equation that is x cubed minus 2x squared minus 5x and then plus 6 equals 0. And we, in chapter 1, we factored this or tried to work it out algebraically. This time we're going to look at it graphically. So what I'd like you to do is type that in to y1. And so in your calculator, if you go to y1 and you type that into the very first equation, that's what we're going to take a look at. Once that's typed in, the window that I used is the standard window, which is when x is from -10 to 10, and then y is from -10 to 10. And you certainly could choose a different window, but that window should be able to find all the things you need to look at. Okay, once you type in the equation and then once you get your window set appropriately, this is the graph that you end up seeing. And we're looking for the x-intercepts of this graph because we're looking at when does this graph equal 0. And that's going to be these 3 points. They actually are all really nice values that you can just see. You could also use the second and let me just write this down. So second and calculate option. You would be using option 2, which is called 0. And that would allow you to identify those values if they were uglier values than what we can see there. And we'll be going through that as well later on. The other option that you could do is press second and graph, and that gives you your table. This is helpful in this particular example just because when y is 0, actually let me just circle this. So when y is 0, those are x-intercepts. So you can actually find them on the table as well. So there's a couple ways to get these values, but we have -2, 1, and then 3. Sorry, and so that is going to be for A, that is going to be the set of solutions. So -2, 1, and then 3. Okay, so now what we're doing is we're trying to figure out this inequality. So again, we had already set this equal to 0. So now what we're looking at is when is this particular equation greater than or equal to 0. So remember, it's kind of similar to what we had done in that previous problem. We're looking at whenever this is greater than, greater than the y values are greater than 0, so above the x-axis. So anything that's shaded in green there is what's going to satisfy that equation. So that would be between -2 and 1. So we have -2 and 1, both are brackets because the inequality is equal to. And then we also have from 3, which is included, to infinity, which is open. And it's because, again, that inequality is closed. That's including the value. So anytime you have x values between -2 and 1, and then from 3 to infinity, that equation will be greater than 0. Okay, that's it for this video. Thanks.